A star is dying right now, somewhere in the depths of the galaxy, and physicists say it might not be doing what we always thought it does. It might not be collapsing into a black hole. It might be giving birth to a universe. Picture this, a star tens of times more massive than our sun, finally running out of fuel after burning for millions of years. Gravity wins. The core implodes in a fraction of a second, faster than you can blink. And for over a century, we've told ourselves a clean, simple story about what happens next. The matter crushes down into a point of infinite density, a singularity, wrapped forever in an event horizon that swallows light itself. That's the black hole story. It's the one in every textbook, every documentary, every popular imagination of the cosmos. Repeated so often, it feels less like a theory and more like an undisputed fact, as solid as gravity itself. But a new theoretical study from physicists at Goethe University in Frankfurt suggests that story might be missing its final chapter. And what's hiding inside some of these dying stars could be something almost too strange to say out loud. A newborn universe, sealed inside the wreckage of an old one. For most of modern astrophysics, the black hole has been the final word on stellar death. When a massive star can no longer generate enough outward pressure from nuclear fusion to resist its own gravity, the collapse is supposed to be unstoppable. Layer after layer of stellar material falls inward, faster and faster, accelerating toward the center like water spiraling down a drain, except this drain has no bottom. According to Einstein's equations, everything eventually compresses into an infinitely small, infinitely dense point, a singularity. Around it forms the event horizon, the boundary of no return, the place where the laws of physics as we understand them simply stop making sense. Cross that line and not even light, the fastest thing in existence can climb back out. It's an elegant idea, and it's also been wildly successful. Black holes have been observed indirectly for decades through their effect on nearby stars. Photographed directly for the first time in 2019 when the Event Horizon Telescope captured that now famous glowing ring of light, and even heard through the ripples of gravitational waves crashing across space-time like sound through water, detected by instruments like LIGO whenever two black holes spiral into each other and merge. Nobody seriously doubts that black holes exist. The evidence is overwhelming, the observations are repeated, and the math has predicted real, measurable phenomena again and again. But here's the quiet, uncomfortable truth that's lived in the background of physics for over 100 years. Nobody actually knows what happens at that final point of collapse. The math doesn't just get complicated there, it breaks down completely. Infinite density, infinite curvature, time and space folding in on themselves with no clear exit, no rulebook, no fallback equation. The universe's laws simply have no answer for what a singularity actually is. It's the equivalent of dividing by zero and being told the answer is somehow real, somehow physical, somehow sitting out there in the cosmos. Physicists have lived with this gap for generations, tucking it away as one of those problems future physics would eventually solve. The way 19th century scientists once shrugged off the strange behavior of light and waited for quantum mechanics to explain it decades later. That gap, that unanswered question sitting at the heart of one of the most famous objects in the universe, is exactly where this new research begins. Theoretical physicists Daniel Jampolsky and Luciano Rezzolla didn't set out to disprove black holes. Instead, they did something physicists love to do when the math gets uncomfortable. They asked, what if the ending is different? What if, instead of collapsing all the way down into a singularity, the dying star's core does something else entirely? Their answer involves an exotic theoretical object called a gravastar, short for gravitational vacuum star. The idea of gravastars isn't even brand new. Physicists have floated it for over 20 years as a way to dodge the conceptual headache of singularities. But there's always been one massive hole in the theory. Nobody could explain how a gravastar would actually form in the real universe. You could write down the equations for a finished gravastar sitting there in space, but you couldn't explain the journey, the actual moment of birth. That's the piece Jampolsky and Rezzolla claim to have finally solved, and the way they describe it sounds like something out of science fiction. except it's published in a peer-reviewed physics journal, run through the same equations Einstein himself used to describe gravity over 100 years ago. As the star's core collapses, instead of crushing down into a single infinite point, the model shows that a tiny bubble of dark energy can form at the very center, a bubble that behaves like its own miniature, expanding universe. That bubble pushes outward, fighting back against the relentless pull of gravity, like a balloon being squeezed from every direction, yet somehow refusing to pop, finding just enough internal pressure to hold its shape against a force that's supposed to be unstoppable. In doing so, it can stop the collapse before a singularity ever forms. No infinite density, no singularity, no point where physics gives up and shrugs its shoulders. Just a strange, layered object. Ordinary collapsed matter on the outside, behaving almost exactly like a black hole to any outside observer, and a baby universe quietly expanding on the inside, completely hidden from view, growing in a pocket of space-time that the rest of us could never reach. Sit with that for a second, because this is the part that should give you chills. We talk about the multiverse like it's an abstract idea, something confined to chalkboards and science fiction movies, a fun thought experiment with no real teeth behind it. But this model proposes an actual physical mechanism grounded in dark energy, gravity, and the same field equations that predicted black holes in the first place. For a new universe to begin, right now, inside the corpse of a collapsing star somewhere in the Milky Way. It echoes an idea some cosmologists have floated for decades, sometimes called cosmological natural selection, where universes essentially reproduce through collapsing stars, each black hole potentially seeding a new cosmos with its own laws of physics, its own constants, its own chance at forming galaxies and stars, and maybe even life. Somewhere out there, if this model is even partially correct, there could be objects that look exactly like black holes from the outside. Same mass, same crushing gravity, same total darkness, same gravitational pull strong enough to bend starlight around them, but which are, on the inside, something else entirely. A seed, a cradle, the very beginning of somewhere else. This matters far beyond stellar physics, because it cuts straight into one of the deepest unanswered questions about existence itself. Where did our universe come from? For decades, the leading idea has been the Big Bang, a single unexplained moment of expansion from an unimaginably hot, dense state, smaller than an atom, that suddenly became everything we see today. But unexplained is the key word, the one cosmologists tend to skip past quickly in documentaries. The Big Bang model tells us in extraordinary detail what happened a fraction of a second after the beginning. It says almost nothing about what triggered it or what came before, or whether before even means anything at that point in time. This Gravastar model offers something physicists have wanted for a long time, a possible mathematically consistent mechanism for how a universe could actually start. Not from nothing, from something, from the violent crushing death of a star, somewhere in some other universe, just like the ones we watch explode and collapse every single day through our telescopes. If that idea is even close to right, it means the death of stars and the birth of universes might not be two separate stories at all. They might be the same story, told from two different sides of an event horizon. An ending if you're standing outside looking in, a beginning if you're somehow standing inside looking out. Our own universe, the one containing every galaxy, every star, every person who has ever lived, might have started this exact way, as a bubble of dark energy expanding inside the collapsing remains of some star in some unimaginable elsewhere, the moment its outward push finally overcame gravity's grip. It would mean the same force that builds galaxies and bends starlight also, occasionally builds entire realities. And this is where the story gets genuinely uncomfortable in the best possible way, because nobody can prove this is what's happening. Not yet, and maybe not for a very long time. Gravastars remain entirely theoretical, a solution on paper rather than a confirmed object in the sky. We have never directly observed one. By design, they would look almost identical to black holes from any distance we could currently measure. Same gravitational pull, same light bending, same dark silhouette against a backdrop of stars. The honest, almost unsettling reality is this. Every black hole astronomers have ever imaged, every black hole merger ever detected through gravitational waves, every single one of them could, in principle, be either a true black hole or a Gravastar wearing a black hole's mask, indistinguishable with today's instruments. Some physicists hope that future, more sensitive gravitational wave detectors might one day catch a faint difference. A tiny echo in the wave pattern after a merger, a subtle signal that wouldn't exist if the object were a true black hole with no surface to bounce off of. But that signal, if it exists at all, sits right at the edge of what our best instruments can currently detect. We simply don't yet have a telescope, a detector, or a method precise enough to peel back the mask and see what's actually underneath. Professor Rizala himself has been careful to frame this correctly. This research isn't an attack on black holes. They remain, in his own words, the simplest and most natural explanation we have for what happens when a massive star dies. But science doesn't move forward by only defending what's comfortable and familiar. It moves forward by chasing the cracks in our certainty, by being willing to ask uncomfortable questions, even about ideas that feel completely settled. And right now, there's a crack sitting at the very center of every black hole in the universe. A place where our equations simply stop working. And nobody knows for certain what's actually inside it. So think about that the next time you see an image of a black hole. That now famous glowing ring of light wrapped around an abyss. The one that broke the internet back in 2019. We call it darkness. We call it an ending. The place where stars go to die and information seemingly disappears forever, never to return. But what if, in some of those countless points of total blackness scattered across the cosmos, something else entirely is unfolding, completely unseen, completely silent? What if endings and beginnings aren't opposites at all, but the same event, depending entirely on which side of the horizon you happen to be standing on? It's one of those ideas that's almost too big to hold on to comfortably, that the universe itself might be a kind of inheritance, born from the violent death of something that came before it. In much the same way, every star that ever exploded scattered the very elements that would one day become the atoms in your body, your bones, the iron in your blood. We don't know if this is true. We may never know for certain. That's the strange, humbling edge of physics at its limits, the place where even the smartest people on Earth have to say, "We're not sure" out loud, and mean it. But the question itself changes how you look at the night sky, even just a little. Somewhere out there, hidden behind an event horizon you'll never see past, there might be a universe just beginning, stars not yet born, light not yet made, a future stretching out in directions we can't even imagine, sealed inside the wreckage of a death that, from where we stand, looks like nothing more than absolute silent darkness. If this story made you look up at the stars a little differently tonight, that's exactly why this channel exists. To find the strange, half-proven edges of science and bring them to you before anyone else does. Hit subscribe so you don't miss the next mystery. The universe is quietly hiding from us. Drop a like if your mind is still spinning a little, and tell me in the comments below. If you had to choose, would you rather live in a universe that ends in nothing, or one that ends by becoming something entirely new?